there we go.
Yeah.
So the reason I wanted to talk to you is because we need to shard more of the recording rules. The reason we need to do that is so the query doesn't run out of memory when it tries to load everything in memory for example, an entire cluster, an entire service, or whatever. So the idea is to break those queries up into smaller pieces. And your suggestion was to do it by cluster because we basically already do that now in Prometheus. We have a Prometheus that's running in a certain cluster and that's keeping an eye on, that's monitoring for certain services. And if we move that as is to Thanos ruler, the new Thanos ruler, then it's just too many metrics at once.
Yeah.
The reason that we in our first plan we didn't want to do that is to be closer to source metrics. So when we do a query, all of the metrics used in that single query get the same timestamp. You know what I mean there, right? So that's why we wanted to do everything from source metrics and use those as much as possible.
Yeah. So, from my understanding, the main importance of the source metrics as well was now we have a separate rule for the denominator and the numerator, which can get a bit of a timestamp split.
Yes, exactly.
So specifically with those, if we could get that in one rule, that would help that a lot.
Yes. So I thought when looking at the whole bunch of JSON that we got, I thought about two approaches. One was basically the opposite of what we set out to do in the first place, is reuse the SLI aggregations. SLI aggregations are like a weird intermediate recording rule that we use before aggregation sets, and in the current state they get automatically generated for all metrics used in SLIs in a service that get a note, add this to recording rule metrics registry. Like there's a small, do you want me to show that, or do you know how it works?
Yeah, that'd be nice for a quick demo.
Yep. Let me share my screen. I need to reboot so everything's gone. Run books. So let's go, for example, to the web service. And here we've got recording rule metrics. That's an array, and it takes a bunch of just metric names. So we were adding HTTP request total, Rails request, and global search recording rule metrics. Those are those are like application SLIs. They are defined elsewhere, but that's generally these metrics. And so that's these kind of metrics that are in there. Now, every time we use those in one of those stanzas here, for example, histogram apdex or rate metrics, if we use one of those metrics in there, inside the key metric file, we'll generate, I'm going to open key metrics web, and on the top, we have those SLI aggregations. Here is for HTTP request total, and it records like an aggregation with all of the labels that are marked as significant labels. Significant labels are part of the SLI. Let me see if I can find one. Here. So here, GitLab workhorse HTTP request total is not included in the registry. So we don't have anything, but for example, here we've got that the Rails requesting endpoint ID is a significant label there, request urgency is a significant label there, feature category is a significant label, and so on. As you can see here, there's no filter at all, no selector at all. But this is happening in Prometheus right now. So we already got the separation by shard. We deploy all of our rules to all of our Prometheuses all of the time, which means some of these, for example, HTTP request total, which is a metric that comes from many different services, that's something that is used everywhere. So even though the web service itself doesn't have any SLI with HTTP request total anymore, other services do, which is why this is still here, for example. Am I making sense up to now?
Yeah, total. Do you envision maybe a world in the future where we generate service level recording rules?
Yes, very much so. So in the suggestion, that's already the case. So I suggested getting rid of all of these SLI aggregations. Like that was the first thought. No, let's get rid of them and just to record the aggregation sets. Aggregation sets are these kind of metrics. Here, GitLab component apdex success rate kind of thing, which now reuse those, and those do have filters. So the idea was like, let's not use as a SLI aggregations at all. And record straight from source metrics with whatever selector. We've got the type web here. The idea was to do that across the board. We already have split up some of those things in Thanos by environment. We could split by service as well. That's for the aggregation set approach. Yeah. So wait, we're kind of mixing the two approaches now. So here we've got a problem that there's no selector at all. And here we've got the problem that it's using SLI aggregations, which is indirect. But ideally, we wouldn't have two files anymore. No more Prometheus, no more Thanos later. We just have a single Thanos. Yeah.
So that would basically blow up into the success versus divided by errors for your normal error calculation, right?
Yes, that's what we use later. So, but that's only currently that's only in Thanos. So here we've got success rates, weights, and then if we go to what's that file called again? Thanos rules auto-generated service. Components. Well, yes, let's use the stage group one. So yeah, those are using feature category. Let's not mix things, make it more complicated. So let's start with Thanos rules. Auto-generated component is in the name. Component metrics GPRD. Now let's look for here we don't have a separation by service, but we could. That's not a difficult change to make. And in the iteration that we have for the new rulers, we already have that. So because we currently only record for web, because otherwise it would be even harder to do. We already make that separation now, and these are using the GitLab component errors that are recorded on the left side here. Now, to split things up more, two IDs went on there. One was reuse SLI aggregations, but apply filters. So all of the metrics, source metrics used in an SLI, all of them, no more this array here, but just all of them that are used generate those SLI aggregations recording rules, so it's the same always. And then we can shard that by all of the significant labels that I mentioned, but also anything we want to add. So cluster is one of them, environment is one of them, service is one of them. I don't know how far we want to take. We could start doing it by region. We could it gives us some options, because everything above that, the aggregation sets, can be agnostic of whatever shard we used before that.
Yeah, and we have the unknown of cells, which will need us to potentially split these up further in the future.
Yes. Yes. But then it doesn't really matter. We could add cells to those SLI aggregations in front, and then everything else doesn't need to care. It's just the aggregation. If we want an aggregation by cell, then we would need to build that, and we probably will. But yeah, in the beginning, it's something to worry about. The disadvantages that I thought of with this approach is that I don't really see how we can combine, though I think we can figure it out later, how we can do the transactional thing of using both sides of a ratio in a single recording, so they are timestamped exactly the same. Another thing, like the quick workaround would be to put them right next to each other in a group, so the timestamp is closer together. But yeah, I don't know if that's sufficient or not.
Yeah, I mean, they obviously execute sequentially in the group. So as long as they're in the right order, they're going to run right after each other. In terms of like chasing that fourth 9 of accuracy, it may not necessarily help get there.
No.
But then again, it's Prometheus. Getting that fourth 9 of accuracy is always going to be a challenge. So
yeah,
maybe we accept that, but let's see.
I think we need to iterate somewhere. So what we're trying to decide now is what the best way is. So that's the SLI aggregations approach with its advantages. I think this is going to be overall the more ergonomical thing to work with as a user of metrics. I can't really speak about the scalability of such, like they were added for that reason in Prometheus, but yeah, that's what I need your input on. So there's that. The other approach was basically continuing what we did before. So back to the drawing board. We get rid of all SLI aggregations, and then we create a new aggregation set here. Like we have prom source SLIs. Those are recorded in Prometheus currently. So we add a new one that is, for example, prom source cluster SLIs that doesn't have a ratio calculation and so on here, like in these formats, but it adds a label cluster. And that's the first set of aggregations. It doesn't use source metric. It can record these transactional things that we can reuse later in the global views, like the metrics that we're interested in. Yeah, so it does allow for this transactionality. It will, that's the biggest disadvantage in my opinion, is we will need to define several of these. For example, I think I've listed them in the issue. Here's the prom source one. We will need those. Let's see. Yeah. So we will need 1, 2, 3, 4, 5 of them. So that would be recording the same-ish source metrics, but with different aggregation labels each time. Yeah.
So in terms of like query efficiency, when the PromQL query comes in, it is with inside a recording rule, obviously, the direct expression that's run, it will shard if there's multiple queries within that expression, it will split those up. So in terms of like efficiency, while operating off source metrics and scoping them as best as we can is ideal, I still think the SLI aggregations is going to be easier for us.
As in to scale Thanos Query.
It's going to be easier to implement, and the scaling will be fine as long as we look at what we're actually drilling down within those expressions. And what I mean by that is that's where the things like label replace come in, which I couldn't see any in there, but it's the actual internal expression that doesn't scale. So as long as we have those scoped to appropriate metric sizes, I don't think we need to go all the way to the source metric. I think we'll get minimal gain by going all the way to the source metric.
I think we can get around the label replace thing in those SLI aggregations. The reason I think we can do that is because we want those things to become. So the main source of label replace in SLI aggregations is a stanza we call combined, and combined combines, yeah, multiple SLIs into one. Let me show that. So let me find an example that's going to be easier. Yes, so here's a combined request rate, which uses these two metrics as, yeah, as one of the sources, as one of the sides of a fraction. So let's let me show you, because that's the transactions primary in the Patroni service. So here. So that was, what was it called? Transactions primary here. So you see these two metrics do the label replace. So we can sum both of them. See?
Yeah. And what
if this would become an SLI aggregation, then we would have this part with all of the labels that are used here, tier, Patroni, yeah, probably the type. Yeah, so type and tier would be on the SLI aggregation, and then here we would use these two. So we would have, like, this metric is not a big problem because it's not huge, like a huge cardinality bomb like we see in Web and Sidekick, but that's the idea. So we wouldn't have the label replace when we do the query for everything with a pod label on it, and the pod label wouldn't be there anymore. Yeah. So that's the main source of label replace. I don't think we would have that in the SLI aggregations. If we do it with, like, if we do it with the aggregation sets, the second approach, it would still be there. Do we have label replace in a lot of the high cardinality things? I don't know.
I mean, Postgres is pretty bad.
It is?
Yeah. Not all of the metrics, some of them.
How come we have so many of them? We've only got there's not hundreds of replicas, there's tens of them.
I can't remember which actual label it was, but there's a label that has a table ID or something like that.
Query ID. Is that the problem?
ID. I think that's the one.
Query ID, yes, that's okay. Yeah, that's going to be a problem. It's the it's a query ID, so every different query without the values in it. So yeah, it's a normalized query. That might be a high cardinality one too. Sorry.
Yeah. Do we actually use that?
Yes.
To filter on anything?
Yes. We use it to go from we can take that query ID, find it back in the logs, and find the query. So if something, there's a nice piece of documentation about that here. If we want to see what query is causing slowdowns and so on, we can see it in metrics, but we don't have those timings in logs or something like that.
Oh boy, we need to get some of these systems on Loki where we can actually do label queries with logs.
I think there's a nice drawing, mapping statements. That's the one. Yeah, here we can see what information is available where, and how do we, how we drill down.
Let's see, yeah.
I can link you that if you want. I will. What did I do now? Yeah, I'll link you that later. So for this, which approach do you think is worth exploring first?
I personally think SLA aggregations, expanding on those might be the right way forward.
Yeah, but then we need to keep into account that we might not get the transactional. We might not, because because the label on, if we try to, let me stop sharing. If we try to do the SLI aggregations, the labels might not match for a certain metric. Take HTTP request total that is used in, but that doesn't matter. Maybe we can get to the transactionality later. I don't know. I need to think about it.
And how much of that would be caused by just inconsistent source metrics? As in, if all of our source metrics had consistent labeling in Kubernetes as they were ingested, would a lot of that problem go away? Are we trying to juggle labels that don't exist on one metric and that do exist on another?
With those transactionality things, no, that's actually mostly the timestamp, like timestamp offset. And for some things, like I think a lot of it could be improved if the recording rules were faster. But right now, the rules are not super fast. So that means that by the time the first one goes, the second one goes. By the time we actually record the ratio, the timestamp between the first recording and the second recording is a significant difference in number of requests that happen. So significant difference in the times a counter was incremented. And that,
And you're saying with the SLI aggregations, you're not sure if we can do the numerator denominator in a single rule?
No, well, not if we want to. Well, it will be harder to do, and the current approach that we do it in uses label replace. So then we have label replace on high cardinality metrics, which is why
The reason I ask is because given the metrics we have in the products and the scale, i.e., if we take Sidekick, which can get up to like 1,200 pods across the board, and then you add in like the shard, the worker labels, etc., they're always going to be slow in a sense. There's only so much we can do to speed those up, because it's just thousands of series of data that it has to load. So if we can get them in a single rule, the better for the timestamps. If we do it sequentially in a rule group, there's still going to be that small offset between the numerator and denominator.
And it's going to be significant.
Yeah, I mean, I wouldn't say significant, but with our request rates, it can skew things quite badly. So I guess the main question is there a way we can do SLI aggregations but still run our
get that transactionality, like have the same?
Yeah.
So we already introduced, like, can we tell somehow in a query use that timestamp? Like we've got offset 10 seconds, but then
no. And it's actually it's actually Thanos actually makes some of these things worse. This isn't actually a problem that Mimir has in terms of amplifying it. So if we say one of the problems is getting the timestamp at the time of the recording rule and having those timestamps different, that's based on how we record the data and when we record it. But Thanos adds another problem, which is because it records and keeps 2 copies of data for every high availability set of Prometheus we have.
Yeah.
It actually stores both sets. It can get O2 or O1 with any, query. Caching aside, like the most recent data that it will ask for could come from either one of those.
Yeah, I know.
Which
I've
could
seen
be
that.
slightly skewed. Mimir drops one of them at write time, so it only ever stores one instance.
So deduplication happens at write instead of at read. Then.
Yeah, and it actually kind of denotes, if you have two Prometheus writing in, or Promethei, say 01, 02, when they send in write requests, it has this thing called an HA tracker that just says, okay, I'm going to say that 01 is considered the only source of truth for now. So it only accepts data from this single instance the entire time until that disappears. And then it says, oh, 01's disappeared. I'm now going to basically promote 02 as the main source. So it kind of gets rid of that additional layer of having duplicate metric sources in Thanos. Yeah. That doesn't solve the problem around the recording rule timings, but
no,
it helps somewhat.
Well, we will be sure that it's from the same Prometheus.
Yes.
Yeah. At least. Okay. I tend to agree with you that SLI aggregations are probably the best thing to explore first, but then we will need to communicate that the fourth digit of precision is something we drop for now, and then we'll just revisit it later.
Yeah, it's a tough thing because the fourth level of precision in a system like Prometheus is always going to be the unreliable digit.
Yeah.
Because of just the way it works. It's not, it's a best effort system. And although we build reliability into it, because of the way Prometheus runs, like when you start up Prometheus, for example, it doesn't say wait to the second on the minute to start running recording rules so they're all in step. It just says I started in 30 seconds, I start recording from now. So especially when you have HA pairs, they restart at different times, you're always going to have a skew with when data is recorded.
How can we structure the rule groups to minimize?
So rule groups run all of their rules sequentially top down. Yeah. So if you started with, say, numerator, denominator, aggregation, or whatever way you wanted to do it, that makes sense. That's since we since there are always going to be the offset, is there merit in just in the source SLI aggregations not having the just having all of the metrics in their own group so they can run as fast as they can and it's whatever, and then we try to then we do the ordering. We don't need to do does it still make sense to have this ordering then, or do we need I mean, it helps in terms of keeping it as close to the time period as possible.
Yeah.
And what I mean by that is, let's say we said we want a particular rule group to just run two things as quickly as possible. So the success and the errors. Let's do those two queries in their own rule group so they run as fast as possible. Well, one always is going to run after the other. So based on how long both of those queries take, there could be a 10-second difference between the first and the second.
Got it.
Now, if we say, let's split them into their own rule groups so they both run at the same time, we still have no control over the interval at which that rule group runs. So we set a 1 minute interval on the rule group, but again, based on when Prometheus
best effort,
it's like we can't guarantee they run in the same time window.
No, what we can do is, like right now, the SLI aggregations rule group that I showed you, it contains right now everything is sequentially, and it's based on the assumption. I don't know if that's true or not, but that was my understanding. So we start with an SLI aggregation. Let me maybe open up a file again and share. We're going over time, Nick. Do we continue, or you want to to call it a day for now.
We can continue for a bit.
Let's go back to the auto-generated key metrics web. So the order here is, so we've got one rule, and we do this per burn rate. Let's confirm that. So we've got here the 1 minute burn rate. Then we've got a new group for the 5 minute burn rate. Yeah, so we've got one per burn rate. And we do them sequentially. So we've got first the SLI aggregations, and then we've got the metrics that use those. That was based on the assumption that if the recording that happened here, it will have that value here. Is that correct or not?
Yes. Yeah. Yeah. So once that the higher level rule runs, that value will be saved, and the sequential rules
can use it.
Will have that, can use it. Yeah.
Okay. So we kind of want to keep that.
Yes. Ideally. I would say it might be worth just pondering on with the SLI aggregations, if there's another way we can do the transactional in a single query. I know you've got a lot more of a history in this space than I do, but I'd be interested to know if there's actually a way we could still achieve it by using SLI aggregations.
I think we might be able.
Because if we can, I think that makes this a much easier option to pick.
Let's see. Total. Let's just see if we can write it in one of these. I think yes would be my hunch. So
you've got errors there.
Yeah, here we've got, let's get rid of this.
And then divide.
So that's.
But why do you need the label replace?
Because otherwise, if I do an or an and here, if the labels are the same, which they are, then or an and, then I'm just going to have one side. So I need to add a label to yeah. Or would that work?
In theory, yes.
Oh, that's nasty. Let's see what happens.
I actually think that is valid. Double check it.
Let's drop that in a. That's a very expensive query to run. Let's add some selectors in there, as we would do.
All the query pods are exploding in the background.
Yeah, that's another thing. No? Like I type these things in this box here, and then I later see that's never going to work. But I let it run, and I did not copy that. This new Thanos text box does something to keep key bindings.
Oh, I've noticed that as well.
And it's kind of annoying.
Especially when I try and hit enter to run a query. I think they swapped around the new line button and
yeah. Does that work? No, we don't have the name in there anymore, no?
I think name gets hidden by default. You'd have to check the results.
How can I do that?
Do you have a aggregation for that SLI aggregation? Like what we're running there, is there a recording rule that wraps up those two existing SLI aggregation rules?
Yeah, but those are source metrics. Those are not those are just source metrics. Nothing special. So I would have thought that it would show me the name.
It should do.
That's too bad.
What's the recording rule name again? SLI aggregations.
GitLab SSI.
Total.
Yes.
Yeah, so that recording rule, what are we actually doing with that and the error total? Those two recording rules.
Yeah, okay. So what you're looking at here is something I messed up, right? Remember? Let's just check it out.
Oh yeah, sorry. I know what you changed. I mean, the original one was the request total rate,
yes,
request error total rate one. So
yes,
we've got an error rate and we've got a total.
Yes.
As SLI aggregation recording rules. Now, what are we using those in, I guess, as well?
Later we would use those. Let me show you. SLI real. We use those to get the success rate and the weight here. This is in an aggregation set. So, and then this aggregation set is later used in Thanos, current Thanos, to turn that into a ratio. And that's where the thing goes wrong. So we can still do the transactionality trick here. So that would be in Thanos only.
Yeah. So that's my question, is if we're recording a total and an error rate, we're obviously running a transaction on that somewhere.
Yes, in the ratio, so now we've got that. Keep in mind SLI aggregations. Then we aggregate that here in component appdex success here. And then later we use that in the Thanos rules. Service, what was the name again? Component?
Mm-hmm.
Service component stage group. Component metrics. So then here we reuse that. Yeah. We reuse those from Prometheus on the left to the right. So we would already improve the distance between, like now we've got three sets. Now we've got SLI aggregations, we've got the aggregation set in Prometheus, and then we've got the aggregation set in Thanos. We could already we get rid of basically this, because we can go straight to the aggregation set in Thanos that provides a global view using the SLI aggregations. And we could record the ratio straight from those SLI aggregations, which is already a transaction then. So that means this recording rule here. So I think we will have improved the situation. We only still have the disconnect between numerator and denominator in the first one.
Yeah, I guess that's the piece I'm still need to get my head around. So the first one, you mean the first
SLI aggregation? Yes.
Yeah. I'm just trying to get my head around why would we running a label replace to join data sets when we have a total and an error? Wouldn't we be running the transaction across a total and an error to begin with?
So if we did this, that's a transaction already. That's good.
That's what I mean. Yeah.
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 So if we did this on source metrics, we're happy, but we're not doing it on source metrics. We're doing it on SLI aggregations. So we want the SLI aggregation, both sides, to be in one thing, but not calculate a ratio yet because they're running on a small piece. They're running on a, for example, a single cluster, and we want the ratio for the entire service, entire environment. So that's why label replace allows us to keep those. Come on. So now we're going to, should have both, but with no. We need an OR. What's going wrong? I would have expected them both to be in here now. Yeah. So that's what I mean. It's actually the other way around, but yeah.
And so that goes back to replacing this situation is option 2 with the source metrics.
No, actually this is if we could, this is doing that on the SLI aggregation. So if we could make an SLI aggregation that takes both sides of a fraction and puts it in one recording rule, we could still do it at the first level. And then we'd be good.
What's recording the GitLab SLI Rails request error total? Request total.
What is currently recording that?
Mm.
The SLI aggregations here. And in our case, we would, like, if we want to get to transactionality at some point, we would
yeah, sorry. What's exposing that metric?
the
SLI Rails request total.
the web faults, like everything that's running Rails.
And there's no unique label between those two data sets.
What do you mean?
Or as in if there was like a label SLI type that said error or total, then you wouldn't need that label replaced, right?
Yeah, we've got the label name now for that, but we can't use that. That's what you're saying.
So what I'm saying is if there was an actual label in the metric that differentiated the two, would that help the situation?
I think it, yes, then we wouldn't need the label replace in there. But it would only work for our SLIs that we kind of like build the metrics for ourselves, like those GitLab SLI things. We can do that. But things like HTTP request total, I don't think. Well, actually, HTTP request total is already, would already do that because it has a status label or a code label, yeah. For histograms, we would also be good because we use the buckets there.
Yeah, the two main ones are histograms for AppDex, and if we're doing generic SLIs, it would be status codes, traditionally.
Yeah. I think I like the idea of, let's try to do that. Change the SLI aggregations to not be, to just be aptX total, and then have a success yes or no on it. And request total that has an error yes or no on it. And then we don't need the label replace anymore. Yeah.
I think that's an easy option.
That's a good idea.
At least with something we have control over, which,
Yeah.
If we get to the situation in the future where we find a new transaction that we want to run where it's hard to differentiate, then we can deal with that then. But
I think it's an excellent idea. I'm going to go through our SLIs that we have, and I think, because all of these things that start with GitLab SLI, they go through like a little frameworky thing we have in our Rails code base, so they're pretty easy to change. They're also, I think, pretty easy to duplicate, so we can have the transaction, like, oh, Nick, you're going to be so angry at me. We're going to emit those records in duplicate, one with the new kind of thing and one with the old kind of thing. So one with the new label and one, you see where I'm going, no?
Yeah, I don't know if Prometheus will be able to handle that, to be honest.
I think, no, I'll figure out a way around it then.
I'm sure we can just put it through a rollout, right?
Yeah.
It shouldn't, I mean, I can't, I won't go there, but as far as I could imagine, it won't break anything because we're already aggregating away most labels anyway, right?
Yes, but we still need those labels. So I think what we can do is on the recording rule side of things, start checking for both. Like we record both, but not all pods will be emitting both. Like it will be.
I see what you're saying. Yeah. Because we have to transition. Yeah.
So on the metric side, the metric side of things, we just check for both. One is going to be nice with a label, another, yeah. I think that can work. And then we don't have the transactionality need anymore. I think one of the no, we will have it still. One of the things that we saw it in was Redis. Yeah, we get rid of that. That's actually good. No, we're still good. The reason that it's still going wrong now is because we have the two levels. We aggregate the operation rate in two separate recording rules.
Yeah.
Ops rate and error rate.
And error rate. Yeah.
Yes, but if we only had one, like because we need to do it in Prometheus first and then we do it again in Thanos across all services, if we get rid of that, we would just use these two metrics to calculate the ratio directly. So we'd be good. I think the idea has merit, and I will look into it further. I will write it down on the issue. So conclusion, thank you very much for your time, Nick, because it's super late for you.
That's all right.
We're going to explore the SLI aggregations first. We're going to see if we can make it so we don't need to record errors and operations or successes and operations into a separate metric. If we don't need to do that, so instead of having the name differentiate between both, we're going to have a label differentiate between both, which makes it so we can record without label replace, which makes stuff cheaper. And we don't need to ensure transactionality further down the stack. And that makes the whole transactionality, in my opinion, a lot easier.
Yeah. We'll obviously still have some work to do with scoping. but in terms of the actual.
The nice thing about when we do, that's what I mentioned on the issue for scoping, because we are using because we're basically doing it directly on source metrics and aggregating away the labels that we're mostly not interested in, pod and so on. We can scope on whatever our infrastructure is already scoped in, like as you mentioned, cluster. If we need to drill more down, like zone, region,
cell in the future,
cell, yeah. It's basically up to us. Like, however, if that's yeah. Shard is another one. I think we can get away with it.
Yeah, well, let's explore that route anyway. I think it's a viable option.
Yeah, awesome. I'm going to have a lot of writing to do today to get that down. Was this helpful in getting some understanding into what our recording rules currently look like? Because I understood that was a bit of a black box for you.
Yeah, I mean, I could obviously sit there and go through the trail of like the top level, what was that recording, and then which one's that recording, and find the source metrics. It was the like, why are we doing some of these things? And that's, yeah, it's helped answer that, especially with the like recording of the SLI metric and Rails. I didn't realize that it didn't have a unique label set, so that's interesting.
Yeah, and that's actually on me. I didn't know that was going to become a problem, and I didn't. Well, we didn't have one before. We had a success rate and an error rate for jobs and so on. Instead, like we had jobs total and jobs failed total. So I just continued down that path.
Yeah, well, it's a thing. A lot of you see in a lot of recording rules as well. They sometimes record in an SLO type, and it could be like a success or an error, or they might put in like a burn rate 5M or something like that, just so they can switch between or filter things based on the type of SLO that they're trying to generate. Which, of course, because that was a source metric, was a little bit more hidden.
Yeah,
that's cool. It's good we have control over it, though. It's an easy fix.
But this one, yes, this one is a pretty easy fix. Well, pretty easy. You know, it's going to take some time, but like, yeah.
Can you like tag me on that when you do it? I'll be interested to see how those are added.
Yeah, I think I'm going to start by writing down everything that we talked about now, and then creating issues to do it. Because like it's a bit of a change, but I think we can get rid of the transactionality stuff then, which is, yeah, cool. But I'll keep you in the loop.
Yeah, sounds awesome.
Thank you very much for your time, Nick.
All right.
Good night.
Have a good one. I'll talk to you
Bye.
later. Yeah.